Hi there. I'm sure you must have heard the phrase Big Bang. Maybe you also know that the Big Bang theory says that the universe exploded into existence and it was super hot and super dense at the beginning. As it expanded, it cooled, giving birth to elements, stars, planets, and then finally, us. In fact, it is expanding now, and it is expanding at a much more faster rate. And at some point in time, it will be expanding so fast that even light, whizzing almost around 186,000 miles per second, might not be able to span the growing distances. Well, a question might arise in your mind that how the hell do we know that universe is expanding? How do we know that it is only the universe that is expanding? Because the universe is comprised of empty space, and empty space is empty space. It has got no borders, no boundaries, nothing. Then what is it that is expanding? Come, let's check it out. Imagine that the universe is the surface of this balloon. The rubber of this balloon is what is known as the empty space in the universe. Well, here are some planets. A star. Maybe throw in a black hole for fun. These may move relatively to each other, hence changing the distances between them. Well, that's common sense. But if the universe is expanding, the distances between the celestial objects will change even if the objects are right where they were in the space. That's absolutely fine. But how did we know that the universe is expanding? Well, to look into that, we must first understand the Doppler effect.
He's the Doppler effect.
Yes. It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
Not too helpful, right? Let's try to understand it in an easier manner. Imagine that the car would emit a wave of light every second. The wavelength and frequency are fixed. Awesome. But what if the car was moving? Well, the wavelength at the rear end of the car would increase due to the relative motion between the wave of light and the car. To maintain the speed of light to be constant, the frequency would reduce itself. This is known as the Doppler effect. Hubble termed it as the redshift. Edwin Hubble was the first astronomer to say that universe was expanding. When Hubble studied the light emitted by faraway celestial bodies, he found out that the frequency was reduced to a redder spectrum of light than the general spectrum. That is, it was redshifted. The situation was pretty much like this picture. After putting in a lot of work and intuition to the situation, Hubble concluded that the universe was expanding. But how could this be possible? So, he decided to take the picture in the past and try to reenact the offstart of the universe. When he reversed it by applying the laws of physics, he found out that the universe was seen to expand from a single point, pretty much like a bomb explosion. So, eventually this was known as the Big Bang. But this was all intuitive and not theoretically proven. So, he tried to reenact the model using a linear mathematical formula that could tell us the expansion speed of the universe at distances ranging from 10 megaparsecs to 100 megaparsecs. This came to be known as the Hubble's equation and the theory, the Hubble's law. Today, Hubble's law is considered the first observational basis of expansion of the universe and serves as one of the pieces of evidence of the most cited support in the Big Bang theory. So even if we go out now to find aliens more than 10 megaparsecs away, we won't be able to find them. Do you know why? Because as we approach them, they will move away from us at a much more faster pace. This is why we won't be even able to reach them.